Hello, this is a group 13. My name is Mohammed Abdul Mohsen, and this is our presentation for the final and last challenge number 8. And this is me, the first one. So, the summary of the presentation, which is like the summary of the whole challenge, which is basically can be summarized as follows: that we are going to take one full lab autonomously, and then we're gonna take another lab by doing a manual control. Each lab is supported with the live video and localization data. So during this challenge, actually we came across many challenges and many design decisions. They can be categorized as 3 different categories: decisions related to hardware, decisions related to softwares, and decisions related to GUI. So regarding the hardware, we decided to have back and front collision sensors that will sense if it's close to the wall, and also we have 2 lidars in the both sides of the crawler, just that will sense the distances from the wall. We decided to use Arduino since it's more reliable than the Photon, and everything is hooked to the Raspberry Pi as our central server to control and to display the localization. So the decisions related to software, which is we implemented 2 strategies for the turning. The first strategy, if the distance from the crawler to the wall it's more than 1,000 based on the reading from LiDAR, then it will know that it needs to turn. And if it senses the wall that it's very close to the wall, so then it will reverse and then will make the proper turn. Also, we enhanced our BID to get a better straight line than we did in the challenge 5. Regarding the elevator cave, actually the elevator cave that we managed to get out of that area by implementing the distance from the wall. If it's more than 1,000, then it knows. So if the distance from the wall is more than 1,000, then it knows that that area is an elevator area and it will not make a turn. The decisions made regarding the localization and the GUI is basically that we decided to replace the location of all beacons to be in the middle of each corridor instead of having that in the corners. That actually gave us, from our experience, better RSSI signal and more reliable signal. Also, we used Node.js for the localization based on the previous challenge, and also that we used it for the video streaming. And that all of that, it goes to the Pi, and then from the Pi we were able to publish or see the web page that contains all of these other services. And for the manual control, we decided to use gaming based key presses, which is, as you can see, which is W for forward and DX and S for different functions. So the used components, as you can see here, we use the crawler, we use 2 lidars, 2 PIR, Arduino camera, Raspberry Pi, XPs, 1 is coordinator, and 4 routers. All of them are in API mode, and 4 battery packs. So this is a system overview. As you can see here, everything is in the crawler part, which is consistent of the Pi, Arduino, and everything that's required to make the communication with the beacons. As you can see, this is the coordinator and the API mode that communicates to the other beacons. And this is the beacon layout, which consists of the XP API mode and Arduino. So it replies back to the RSSI request initiated by the coordinator. As you can see here, this is our system implementation overview. This is like the website along with the video, key presses for the manual control, and that's the map. Also these buttons for auto and manual start and stop, and that's like the full setup of the car with all components there. So during the implementation, we encountered many challenges, some of them related to auto and manual mode. So we had an issue that if we implement everything and we tuned all the parameters for auto mode, we had an issue with manual mode. So we tried to figure out a way to make a balance between these two. For the localization beacons, we managed to resolve that problem with the stability of the readings of the RSSI readings by replacing or find a better location for all parameters, for all beacons. We faced a power issue related to PI when we connected all the 4 surfaces, Wi-Fi, Arduino, coordinator, XP, and the camera. We had a power issue with the pipe because it was not able to feed all of them, and we managed to solve that by connecting the power from the car to the Arduino. That's after the startup, so it will take the power from there, and then the pipe will manage to distribute the enough power to the other surfaces. Okay, so this is an overview of the work has been done by every member, and with that I would love to conclude my presentation, and now we will go with the demo. This is a demo for the manual mode. In this we will take two corners. Let's start with the first one. So this is the first corner, this is the first turn. And since the wall, so that is reversing back, so we're gonna try to go more left, and then now we will continue straight. As you can see here, this is our position in the localization. So now we'll go left, so it will sense the wall, and then it will return back and stop because of the back collision sensor. And then now we will try to go again more left, and we'll go straight.